a resistive load. It is our load, which is a resistive load here, which is the end point. This one is the A, this one is B, voltage at B, voltage at C. So we are able to compute line to line voltage and line to neutral voltage here. So we need to have B, A, B. We need to have compute again here B, B, C, and we generally check out the BAC, B, B, A, C. So these are the very important things we need to have find out. So BAB, BBC, and BAC are the important parameters we have to find out after all here. So BAB, BBC, and BAC are so-called the line to line voltages, line to line voltage. And again, we have a line to neutral voltage, line to neutral voltage. So these line to neutral voltages are so BAN, BBN, and BCN. These are line to line voltages. I mean line to neutral voltages, and these are line to line voltages BAB, BBC, BAC. So first of all, we have to know that the voltages generated from this kind of inverter is two type of voltages. The first one is the single phase line to line voltage, line to neutral voltage, as we have seen like voltage at AN, voltage at BN, and voltage at CN. The second thing is voltage at line to line voltage, AB, voltage at BC, and finally we have find out voltage at AC. So these are the very important things you need to know about in inverter case. Yeah. So basically, this is the source what I mentioned earlier. So this is the DC source, and this is the AC source. Now, let's say the cumulative power which gonna insert to this sources, let's say 715 voltage DC. So this 750 volt DC is converted into AC by the help of this controlling mechanism here. So which is directly implemented for the load. Our load may be like here the resistive load, where I said that. So let's remove the resistive part here. The resistive part here, we have a motor here, three-phase motor. So loads are coming in such a way here. So this is our induction type or synchronous type motor, electric motor. So this is our load.